So I've bought this one on eBay, what we see here, which is a full H-bridge PWM to control power motor. So what we can see here is that we have a 43 amp, which is a lot of power. So if we will go to the spec of this one, first of all, I bought it from World Chips. We can see in the specification that we have double BTS 7960 43 amp H-bridge. This one can carry a human, I think up to around 100 kilogram, which is a lot. And we also can see that the supply voltage can be between 5.5 volt to 27 volt, and it is isolated, which is a very nice feature. The isolation is very important because if you have a problem in the power section, it will not affect our controller. Okay, so we can see here we have a 74HC244, which is a buffer, isolated buffer, I think. And we have the H-bridge controller, which are BTS7960. And what I want to show now, I've got them on eBay and I want to check that they are working well. So what I did, I wrote a small program that will do a very simple thing that I have talked about, which is getting PWM out of the Arduino. We have a specific pin that can directly by command send PWM output, which is pulse width modulation, and with this feature we can also control the speed of the motor, because this DC motor, if it gets DC voltage, it will spin at a fixed speed. But if you will toggle one of its pins, let's say the ground is connected all the time and the VCC is toggling to 50%, so we will get a lower speed. Okay. So what I've done here is very simple. I've declared for 2 motor output. This I will show here. Okay, we have this module. This module has if we will flip it, we can see it have a voltage plus and minus, and also motor plus and minus. Okay, so we just need to connect this one in this side to power and the motor, and then by these pins we can control how it will spin. And it is very simple. We have 2 PWM input, so if one of them is connected to ground and the other one is connected to PWM, it will spin to one side, and if we will do the opposite, it will spin to the other side. This is the H-bridge feature. So this is exactly what I've done here. Declare about the outputs. Also there is something wrong with this datasheet on eBay, because they write here that all you need to do, just need 4 lines, which are G and D 5 volt PWM and PWM2, which is not correct. I've tried it, because we have also 2 enable pins, so we have also to give enable to the right side and to the left side of the bridge in order that it will work. Okay, so what I did is very simple. The PWM can be between 0 and 255, which is DC maximum output 100%. So what I'm doing, I'm spinning it. I'm going between 1 to 255 in one direction, and each jump will be 50 milliseconds, and then I'm doing the opposite way. The opposite way, which means pin 5 now is the PWM and pin 3 is the GND. Okay, so let's now see how it is working. We can compile it and then upload. Okay, it is already running. So here is my motor. In order to check that it can work with a power motor, I bought on eBay a wheelchair motor. A wheelchair of course can carry a human being, and this motor 24 volts, so I can supply 24 volts for my power supply, or I can even work with this one on a lower voltage. So I will work on, let's say, 16 volts in order to see that it is working. This is enough for me. Okay, we will wait for our regular power supply to power on. Okay, and then we will do the 16 volt. And limit the amperage to 2 ampere. This is enough. And now we will see that the motor is running and changing after it reaches 225 the direction of the rotation. We can also hear now the 501 kilohertz of the PWM, which I talked about. What is happening here is that we can hear also the sound of the motor, because actually we are giving the large coils on the motor a frequency that our ears can hear. So this is because we are working in PWM that its frequency is too low. The good way, the better way, let's say, to work with this one is not with Arduino, or with Arduino in a different method. And the different method is to rotate the PWM at a frequency that is higher than 10 kilohertz. 10 kilohertz or even 20 kilohertz. This is something that our ears can't hear, and it is good for PWM. Okay, let's close this one. Okay, this is the demo for today. Thank you very much.